Hello everyone, welcome to Edu-Malanga. On Edu-Malanga we create mathematics tutorial videos for the Matric syllabus of South Africa, and our tutorial videos are available free of charge on social media. Today we are working on the third unit of the year. This unit looks at exponential and logarithmic functions. We're starting by doing revision of some of the things that we did in grade 11, and what we're revising today are exponential functions. So an exponential function will take the form y is equal to a to the power of x. The exponential function will have an exponential expression as part of it. I hope you know and understand exponential expressions very well. If you don't, please go back and watch the previous video. Not only did we introduce and explain exponential expressions, but we also looked at exponential laws. So this is the basic form of an exponential function. It's got a domain, which is the x, right? The domain is all the input values, and it's got a range, which is all the y and output values, and we can represent it on a Cartesian axis as well, where we would draw the x and the y values, and then we would denote the relationship between these values. So what we're going to do is we're going to come up with our own exponential function. We're going to keep it very simple for a start. The exponential function that we're going to come up with is going to be this function. Y is equal to 2 to the power of x. If we had chosen y is equal to 1 to the power of x, it would stay 1 forever. So the simplest exponential function that we can come up with is y is equal to 2 to the power of x. Let's write down the domain and the range now of this function. So we have x, and then our range would be y, which is equal to 2 to the power of x. If we choose values of the domain that start from -5, -4, -3, -2, -1, and then 0, then we go to 1, 2, 3, 4, 5. So we've chosen values of the domain that start from the negative and go all the way to the positive. Now we're going to put these into the function, and we're going to find out what the values of y are. 2 to the power of x when x is -5. So what's going to happen here is we're going to have 2 to the power of -5. Again, if we recall, when we did the laws of exponents, there was a negative power law, and this law states that when you have this, it's also equal to 1 over 2 to the power of 5. So let's find out the solution then. 2 to the power of -5, if you put it in your calculator, you'll find that it's equal to 1 over 32. And if you put 2 to the power of -4 into your calculator, you'll get 1 over 16. Let's continue. 2 to the power of -3 is equal to 1 over 9. 2 to the power of -2, that's 1 over 4. 2 to the power -1 now, it's 1 over 2. And 2 to the power of 0, so we no longer have the powers being negative. Again, when you have 2 to the power of 0, if you remember exponential laws, this is the 0 power law, and it states that any number to the power of 0 is equal to 1. Let's continue now finding the values of the range of the function. 2 to the power of 1 is simply 2. 2 to the power of 2, that's 4. 2 to the power 3 is 8. And 2 to the power 4 is 16. And lastly, 2 to the power 5 is 32. So we now have the values of the domain and the range for this exponential function. Let's draw this exponential function now on a Cartesian axis. We'll start by looking at the 0, 1 value. So when x is 0, our y is 1. When x is 0, our y is 1. Let's go to the negative side. When x is -1, your y is 1 over 2. And when x is -2, your y is a quarter. Let's draw that. -1 goes to about half, which is there. -2 goes to a quarter, which is maybe about there. I'm estimating on this axis. And the next value we have is -3 is 1 over 9, even smaller, and -4 goes with 1 over 16. Okay, so -3, 1 over 9, even smaller and even smaller. And the last one, when you have x is -5, your y is 1 over 32. So I'm going to keep estimating. It seems to be getting even smaller and smaller and smaller. On the positive side of things, let's look. When your x is 1, y is equal to 2. And when your x is 2, y is equal to 4. Let's draw it on the axis. When your x is 1, y is equal to 2. And when your x is 2, y is equal to 4. Our axis ends at 10, so the last one that we can draw is when x is 3, y is equal to 8. So let's go. When you have 3, then you go to 8. Let's draw this function. The function looks like this. Okay. It goes like this. And on this side, it keeps getting closer and closer and closer, and it just gets smaller. So this is our function. I'm going to write down some of the values. For example, when x is 3, y is 8. Yes. And when x is 2, y is 4. So this is the graph of this function. Now taking a look at just this graph, what we're going to do now is just discuss some key features of it. These are key features that are applicable to many or most exponential functions, especially when it's in the most basic form, which is y is equal to a to the power of x. You can make some changes to these features by translating the graph, but we're going to look at that more in detail when we are doing examples. So let's continue and look at the features that we can see on this graph. The first noticeable feature when you look at it is that the y-intercept is equal to 1. So here you have 0, 1, and that is your y-intercept. So that is the first feature. Y-intercept is equal to 1. Why does this happen? Again, this is the result of our zero power law. On the y-axis, x is equal to 0. So for this function, you'll get y is equal to 2 to the power 0. The zero power law states that any number to the power of 0 is equal to 1. So that's why your y-intercept is equal to 1. The second feature that we will notice when we look at this graph, if you look at the graph itself as well as the values of the range specifically, even though in the domain you're starting from -5, -4, and you go all the way to positives, what happens in the range though is that your numbers are getting smaller and smaller and smaller. They don't become negative. So how do we describe this behavior? We say that the graph has a horizontal asymptote. The horizontal asymptote of this graph is the x-axis. So in this case, it's the line where y is equal to 0. An asymptote of a graph occurs when you have a line in which the graph will get closer and closer and closer, but it will never be it actually. So for example, the smallest number that we had, when x is -5, y is equal to 1 over 32. Let's check, for example, where x is equal to -10. If you put that in your calculator, your y, which is equal to 2 to the power of -10, is going to equal to 1 over 1024. This number is very, very small, but it's not equal to 0, right? So the graph is going to get closer and closer and closer to the x-axis, but it will never touch it, and that is why we call the x-axis the horizontal asymptote. Let me also say y is equal to 0 or x-axis, and that is the horizontal asymptote of the graph. Let's define our domain and our range. Our domain starts from the negative all the way to the positive, so this will be the third feature. It will say that the domain values are elements of all the real numbers, right? It starts from minus infinity and goes all the way to positive infinity. All the values are applicable, and that's the domain of our exponential function. Let's look at the range. So now everything starts from the x-axis and goes up, and furthermore, the x-axis we've already said is an asymptote, so the graph won't even touch it. So how do we write down that range? We say that our range, again, is an element of all real numbers, but we add an extra restriction, and that is that our y, which is the range values, yes, must be greater than 0, on top of them being elements of real numbers. So our domain is our x values, yes, and our range is our y values. So this is the domain and the range of this graph. So we've looked at this graph and we've written down some of the key features that we see of it. Let's come up with a graph of y is equal to 2 to the minus x. So we have now y is equal to 2 to the negative x, and write down the key features of it in relation to this one as well. Again, we're going to start with the domain x, then we're going to have our range, which is y is equal to 2 to the minus x. Our x values will stay the same, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. These are the values of the domain. Let's come up with the values of the range now. So 2 to the power minus negative 5. So the negatives are going to cancel out in this case, and you're going to get a positive. So this one will be 32. Let's check the next one. 2 to the power minus negative 4, that's equal to 16, okay. To the power minus negative 3 is equal to 8, and this one is 4, okay. 2 to the power minus negative 1, that one is 2. 2 to the power minus 0, we can't have a minus 0, it just becomes 2 to the power 0, and that's 1. Then what happens is we start to have 2 to the power minus 1 is 1 over 2. It looks like we basically have the same thing, but the values of the range are now starting from being big in the negative x-axis, and they're getting smaller as the x-axis becomes positive. 2 to the power minus 4 will be 1 over 16, and the last one we'll look at is 2 to the power minus 5, that'll be 1 over 32. Let's again draw this, and we will have pretty much what we had before, right? 0, 1, okay, so this point will be there, and then as we go, if we start on the negative, we're going to have negative 5 going to 32. We can't draw it on our axis because it ends at 10, so we'll only start drawing at negative 3, which goes to 8. So when you have negative 3, you have it going to y is equal to 8. And when you have negative 2, you have 4, and negative 1 goes to 2. So let's come back and draw it. When x is negative 2, the y is positive 4. And when x is negative 1, your y is positive 2. This is the graph. On this side, when your x is 1, your y is 1 over 2. And when it's 2, it's a quarter. So let me draw it. When it's 1, it's a half again, yes, and then it's a quarter. So this is looking like a reflection about this axis because your values are going to get smaller. 3 has 1 over 8 and 4 has 1 over 16. So it gets smaller and smaller and smaller. Again, let's draw this graph. The graph is looking like this. Yes, it's looking similar to the one that we had for y is equal to 2x. Let me write down some values as well. You have negative 3 goes to positive 8, negative 2 going to positive 4. So this graph is a reflection of this one about the y-axis. Let me write down the equations. This one is y is equal to 2x, and this one is y is equal to 2 to the power minus x. Let's start our observation by looking at this graph. On this graph, our base is 2, which is a positive number. So this will be the fourth observation, and that is when a, which is the base, is greater than 1. Our base is 2, which is greater than 1. Then what happens is, as the x values become large and increase, so do the y values. As x increases, yes, y increases as well. And let's look at the second graph. Now on this graph we have y is equal to 2 to the power minus x. Remember the negative power law? Let's write this down like how it is. So according to the negative power law, when you have 2 to the power minus x, that is also equal to 1 over 2 to the power of x. There was also another law, and this law was the power of fractions law, and that said that when you have a fraction like this, for example, 1 over 2, and your power goes outside the brackets, like this x, the power goes into each of these terms, and so you'll get it's equal to 1 to the power of x divided by 2 to the power of x. 1 to the power of anything is equal to 1 anyways, and so that's equal to 1 over 2 to the power of x. Can you see then that in this function, the base a is actually a fraction, which is 1 over 2. And when our base was a fraction, what happens is that as the x values increase, the y values decrease. And so it has an opposite relationship. So when 0 is less than a, which is less than 1, this means that a is a fraction. As x increases, your y decreases. So you start to have an opposite relationship. The last observation that we can see, which is relevant to all these functions, is that when you have one x value, that x value has only one y value. And this is the fifth observation. So when you have one value of x, it goes with one value of y. For example, 3 goes to 8 only. There's no other values that correspond with a domain of -3. And so these are all the observations that we can make from looking at this exponential function. I hope you understand everything that I've explained. This is just a revision of exponential functions. What we're going to do last is we're going to speak about some of the things that you can do to exponential functions. Let's get started. Remember, we started with y is equal to a to the power of x. And so what would happen if you added a constant at the end plus p? The addition of the constant p at the end causes a vertical translation. So what happens with this graph, for example, if it looked like this, when you add p, it's going to translate vertically up, and it's going to look like this, and this translation will be equal to p. The next kind of translation that the graph can also have on top of this one, so we'll keep this equation, we can have y is equal to a to the power of x plus p. We can get minus q on our power, and what does this do? It causes a horizontal translation. So if your graph, for example, was looking like this, and then you change your power from being just x and you make it x minus q, which is a certain number that you can choose, what will happen is that your graph is going to translate horizontally, and it will look something like this, or it will go to this side depending on the value of q. The last modification that you can make to this function is multiplying a constant in front of your base. So the equation would then become y is equal to b times a to the power of x minus q plus p. And this constant is going to affect how slowly or how quickly your graph rises. So it can either go this way, or it can then rise slower, or it can rise even faster depending on the value of b. What I'm going to do in the next 2 lessons is I'm going to do examples of exponential functions. These examples that I'm going to do are going to be more complicated than y is equal to 2 to the minus x or y is equal to 2 to the power of x. They're going to start taking more of this form, and so join us in those examples, and then you'll be able to understand the effect of b, the effect of q and p more clearly from the examples. Thank you for joining us for this video. I hope you are able to follow. If anything confused you, leave some questions for me in the comments and I'll be able to respond to you.